Hello class, this is lesson 4-6 about how to compute with scientific notation. And to be successful, you need to recall the multiplication and division rules for exponents. So our first example says that scientists estimate that there are over 3.5 times 10 to the 6th power ants per acre in the Amazon rainforest. If the forest covers about 1 billion acres, find the total number of ants. So we are going to actually use multiplication to figure this out. We're going to take the number of ants that are per acre and multiply it by the 1 billion acres. So I'm going to write out 1 billion for you to see that number. The first thing that we should do is to rewrite that 1 billion in scientific notation. And since there are 9 zeros, it's going to be times 10 to the 9th power. Now what I'm going to do is I'm going to just take the starting numbers, the 3.5 and the 1, and I'm going to multiply those together. And then I'm going to take the powers. So I'm going to take the 10 to the 6th power times 10 to the 9th power, and I'm going to multiply those together. So here we go. 3.5 times 1 is still 3.5. And when I add 6 plus 9, I get 10 to the 15th power. So that is approximately how many ants are in the rainforest. Crazy. Our next example says a dime is 1.35 times 10 to the negative 3 meters thick. What would be the height in meters of a stack of 1 million dimes? So again, we are going to use multiplication to figure out this problem. So let's take the thickness of 1 dime and we will multiply that by 1 million dimes. So I'm going to write out 1 million all the way. There we go. And I'm going to take that 1.35 times 10 to the negative 3 and multiply it by 1 times 10 to the 6th power, because that is 1 million in scientific notation. Now I can multiply my starting numbers again, and then I can multiply just the powers. So I have 10 to the negative 3 and 10 to the 6th power. 1.35 times 1 is just 1.35. And when I add negative 3 and 6, I get positive 3. So my final answer is 1.35 times 10 to the 3rd power meters high. So it's pretty high if you stacked up all those dimes. Our next example says a neuron in the body is about 5 times 10 to the negative 6th meter in diameter. A tennis ball, though, is 0.04 meters in diameter. About how many times as great is the diameter of the ball than the neuron? So for this problem, we're going to use division because we want to figure out how many diameters of the neuron can fit into the diameter of the tennis ball. So let's take the diameter of the tennis ball and divide it by the diameter of the neuron. Okay. And like we did before, let's rewrite them so they're both in scientific notation. So that's 4 times 10 to the negative 2 power divided by 5 times 10 to the negative 6th power. And now I can separate these into two parts. I have 4 divided by 5, so I can really just write that as 4/5. And then I have 10 to the negative 2 divided by 10 to the negative 6th. So I can multiply that by this new fraction. Okay. There we go. All right, so now I'm just going to keep that 4/5 for the moment, but 10 to the negative 2 divided by 10 to the negative 6 is 10 to the positive 4 power. And I'm going to rewrite 4/5 as 0.8. And then one more step, let's turn this into an integer times the power. So that would be 8 times 10 to the 3rd power, or 8,000. And this is how many times larger the tennis ball is compared to the neuron's diameter. Okay. This final example here says recently the population of China was 1.3 times 10 to the 9th power people. while the US was 308,745,538 people. About how many times greater was China's population than the US? So again, we are going to use division to figure out this word problem because we want to find out how many times can our population fit into the size of China's population. So let's start with China's population and divide it by that huge number that we have for the US, 308,745,538. And I'm going to just rewrite the China population. And I want to turn the US population into scientific notation. But since it says about, I'm not going to write out this entire number. So I'm just going to kind of round it. So I'm going to say 3.09 times 10 to the 8th power. Okay? So when I do this, like I did before, I can simply take my first two values and I can divide those. And then I can also multiply that by my powers being divided. So 10 to the 9th power divided by 10 to the 8th power. Okay, so this time is a little bit more difficult. I'm going to divide those, and it's going to give me a very long decimal, so I'm just going to round it to 0.42, and that's going to be times 10 to the first power, so I'm just going to write times 10. And when I multiply those values, I get 4.2 times as large, so that is about 4 times bigger than the United States population. And that's it. So to wrap up, I have 2 more examples for us. But this time we're not going to be multiplying or dividing. We're going to be using addition and subtraction. So when you are adding or subtracting using scientific notation, the best tip that I can give you is to rewrite all of your values so that they match the largest power. Okay, if you can all have them have the same power, it's so much easier. So in this case, the 9 is the biggest exponent. So when I rewrite my second value, I get 0.284 times 10 to the 9th power. And now what I can do is I can just subtract my initial values, 1.45 minus 0.284. And all of that will be multiplied by 10 to the 9th power. So when I do that, I get 1.166 times 10 to the 9th power, and I'm done. It's that simple. For our second one, I'm going to rewrite my first value here. So it's going to be rewritten as 0.841 times 10 to the 4th power. And this way, they both will have 10 to the 4th power. And now, like I just did, I'm going to add those initial values together. So 0.841 plus 9.71. And that's going to be multiplied by 10 to the 4th power. When I do that, I get, let's see here, 10.551 times 10 to the 4th power. But remember, in scientific notation, I can only have one value before the decimal point. So it's going to be 1.0551 times 10 to the 5th power. And that's it. So to conclude, I have one problem for you to try on your own. You're going to add up these 3 values, and we'll see how you do. So when you come to class, let me know if you have any questions. I will see you then.